Hello, in this lecture we will find the area of the yellow circle. We have in the drawing semicircle, and the center of this semicircle is at point O, and we have point of contact between those two circles, between the yellow circle and the semicircle. They touch each other at point P, so point P is the point of contact. And we also know that PQ equals to 7 times root 2. Let's call the center of the yellow circle M, actually, in order to find the area of the yellow circle, we have to find the radius of this yellow circle, because we know that the area of a circle, the formula for the area of any circle, we will call the area A. The area of any circle equals to pi times the radius square times r square. So A equals to pi times r square is the formula for the area of any circle. So the area equals to pi times the radius of the circle. Pi times the radius square of the circle. The square of the radius times pi is the area of any circle. So as you can see, that the only variable that is missing in order to find the area of the yellow circle is the radius. Okay, so the only thing that we have to find is the radius of the yellow circle. So actually we will connect points M and O together, and as you can see, M is the center of the yellow circle, and O is a point on the yellow circle. Therefore, MO is defined as the radius of the yellow circle. So we will call it R, abbreviation for radius. So R, small r, is defined as the radius of the yellow circle, and it is actually equals to MO. The size of MO is the radius of the yellow circle. Okay, so actually we have a rule. Let's call it rule number 1. That states, rule number 1 states that if two circles touch each other, then their point of contact so if two circles touch each other internally or externally, I will add it can be internally or externally. I will add this internally or externally. Okay, I will write it again. So rule number 1 states that if two circles touch each other internally or externally, then their point of contact lies on the straight line joining the centers. So I will read again rule number 1. Actually, rule number 1 states that if two circles touch each other either internally or externally, then their point of contact lies on the straight line joining the centers. Okay, now I will explain rule number 1. Actually, rule number 1 states that if two circles touch each other internally or externally. So the yellow circle touches the semicircle at point P, internally at point P. And actually point P is the point of contact between those two circles. So rule number 1 states that their point of contact lies on the straight line joining the centers. So the point of contact P lies on the straight line joining the centers. That is to say, the line segment MO that joins the two centers together, because M is the center of the yellow circle and O is the center of the semicircle. And MO, the line segment NO, connect the two centers together. So this line segment MO creates with the point of contact P a straight line. That is to say, PMO is a straight line, or OMP is a straight line. Again, I'll explain rule number 1 again. If two circles touch each other internally or externally, the yellow circle touches the semicircle internally at point P, and point P is also called the point of contact. So this point of contact, point P, lies on the straight line joining the centers. Point P lies on the same line as the segment line MO that connects the two centers together. That is to say, OMP is a straight line, because point P creates with the line segments that joins the two centers together, that is to say, with the line segment MO, P creates a straight line. That is to say, PMO is a straight line, or OMP is a straight line. Okay? So, again, the yellow circle touches the semicircle at point P. Point P is the point of contact. So, those two circles touches each other at point P internally. And the rule number 1 states that the point of contact, that is to say point P, lies on the straight line joining the centers. That is to say, PMO is a straight line, because point P creates with the line segments that joins the two centers together a straight line. That is to say, PMO is a straight line, or OMP is a straight line, because point B, the point of contact, creates with the centers, with the two centers, a straight line. That is to say, PMO is a straight line. That is exactly what rule number 1 states, because it says that the point of contact lies on the straight line joining the centers. So the point P with the line that the line segment that joins the two centers together, that is to say segment line OM or MO, point P creates with MO a straight line. That is to say PMO is a straight line or OMP is a straight line, because point P creates with the line segment that joins the two centers together, that is to say the line segment OM, a straight line. That is to say PMO is a straight line. Okay? I will explain again. If two circles touch each other, in this case internally, the yellow circle touches the semicircle at point P. Point P is the point of contact. So this point of contact P lies on a straight line. It actually creates, point P creates a straight line with the line, with the segment line that joins the two centers together. So MO is the segment line that joins the two centers together, and point P creates with MO a straight line. That is to say PMO is a straight line. Okay? Because the segment line that connects the two centers together is MO, and point P creates with MO a straight line. That is to say PMO is a straight line. Okay? Or in other words, we can say that PO is a straight line. Okay, PO is a straight line, and PO is a straight line, so MP is line segments that starts from the center of the yellow circle and ends at point P on the yellow circle. For that reason, therefore, MP is also defined as the radius of the yellow circle, because it starts from the center of the yellow circle, and ends at point P, that is a point on the yellow circle. For that reason, it is defined as the radius of the yellow circle, because any radius is defined as a segment line that starts from the center of the circle and ends at any point on the circle. For that reason, MP is also the radius of the yellow circle. So we can see that OP also equals to 2 times R. That is to say, OP equals to the diameter of the yellow circle. OP equals to the diameter of the yellow circle. PO is a straight line. OP equals to 2R. As you can see, OP equals to 2R. And OP also equals to the diameter of the yellow circle, because the diameter of any circle is defined as 2 times the radius. So OP is also the diameter of the yellow circle, but because of the fact that OP is a straight line and it exits from the center of the semicircle and ends at point P, that is a point on the semicircle, for that reason it is also defined as the radius of the semicircle. So we can mark it as capital R. So capital R equals to the radius of the semicircle. Okay? Again, because of the fact that OP is a straight line, according to rule number 1, and it starts from the center of the semicircle, that is to say from point O, and ends at point P, that is to say point that is on the semicircle itself, it is defined also as the radius of the semicircle. Okay, I will write it down. OP equals also to the radius of the semicircle. Okay, OP that I defined it as capital R also equals to the radius of the semicircle. And actually, for the same reason, also OQ will be equal to the radius of the semicircle. Because of the same reason, exactly, because OP starts from the center of the semicircle and it ends on point Q, that is a point on the semicircle itself. For that reason, OP is also the radius of the semicircle. Okay, I will write OQ equals to the radius of the semicircle. OQ also equals to the radius of the semicircle. Okay, so OP is the radius of the semicircle, and also OQ is the radius of the semicircle, and I mark the radius of the semicircle as capital R. And what we can also conclude from the drawing, that actually we can see the relationship between capital R, the radius of the semicircle, to the small r, the radius of the yellow circle. And as you can see from the drawing, capital R equals to 2 times small r. I will mark it as equation number 1. So equation number 1 states that capital R equals to 2 times R, because as you can see from the drawing, OP equals to the radius of the semicircle. OP equals to R, to capital R, from one side. But from the other side, you can also see that OP equals to the diameter of the yellow circle. And the diameter of any circle equals to 2 times the radius of that circle. Okay, so from one side we have OP that equals to R. From the other side we have OP that equals to 2 times small r. From one side OP equals to capital R. From the other side OP equals to 2 times small r. Therefore, we can deduce from those two equations that R equals to 2 times R, or capital R. Capital R equals to 2 times small r. Okay, very simple. So you can see it from the drawing, or you can arrive to the same conclusion by simple logic. Okay, so we know that the relationship between capital R to small r is that capital R, that is to say the radius of the semicircle, equals to 2 times the radius of the yellow circle. Okay, that will be equation number 1. But we also have rule number 2 that states that in any circle a radius and the tangent to that radius are perpendicular to each other. So I will read again rule number 2. So rule number 2 states that in any circle a radius and the tangent to that radius are perpendicular to each other. So if, for example, we have a radius, let's call it R, and we have also tangent to that radius, let's call it T. Then the radius is perpendicular to the tangent, to its tangent. That is to say, this angle equals to 90 degrees and also this angle equals to 90 degrees. Okay, so again, in any circle, a radius and the tangent to that radius are perpendicular to each other. That is to say, this angle is 90 degrees and also this angle is 90 degrees. We actually can implement rule number 2 in our circles, because in our circle we have radius MO of the yellow circle, and we also have OQ, line segment OQ, that is tangent to the radius. So we have radius and the tangent to that radius. So according to rule number 2, they are perpendicular to each other. So actually angle POQ equals to 90 degrees. And for the same reason, we can say that angle POL will be also equal to 90 degrees. But what is important for us, that angle POQ equals to 90 degrees. Because the radius, that is to say AMO, and the tangent to that radius, that is to say OQ, are perpendicular to each other. For that reason, POQ equals to 90 degrees. Because R is perpendicular to OQ. So it creates 90 degrees between itself to the tangent. So this angle equals to 90 degrees. So as you can see in the drawing, we have right triangle POQ, because this angle is equals to 90 degrees, and we know that PO equals to capital R, we know that OQ equals to capital R, and we also know that the hypotenuse of this right triangle equals to 7 times root 2. So I will draw again the right triangle POQ, and we will use the Pythagorean theorem in order to find out the value of capital R. Okay, first of all, I will draw the right triangle POQ. Okay. So I drew triangle the right triangle POQ. As you can see, side PO equals to capital R, also side OQ equals to capital R. Those are the perpendiculars, and the hypotenuse of the right triangle equals to 7 times root 2. So we easily can implement the Pythagorean theorem in order to find out the value of R. So actually the Pythagorean theorem states that Pythagorean theorem So the Pythagorean theorem states that the square of the hypotenuse in a right triangle because it applies only to right triangles. Equals to the sum of the squares the sum of the squares of the perpendiculars. So I will read again the Pythagorean theorem. It relates only on right triangles. So the Pythagorean theorem states that the square of the hypotenuse in a right triangle equals to the sum of the squares of the perpendiculars. So actually, if we have a right triangle A, B, C, if we have right triangle ABC, then the square of the hypotenuse, that is to say AC square, equals to the sum of the squares of the perpendiculars. That is to say AB square plus BC square. Again, the square of the hypotenuse, that is to say AC square, equals to the sum of the squares of the hypotenuse, that is to say AB square plus BC square. Okay, so according to the Pythagorean theorem, we can say that in our circle, actually PQ square, the square of the hypotenuse is PQ square, and this PQ square equals to the sum of the squares of the perpendiculars. So the first perpendicular that we have is PO, so it's PO square plus OQ square. Again, the square of the hypotenuse, that is to say PQ square, equals to the sum of the square of the perpendiculars. We have two perpendiculars, OQ and OP, so it is PO, it is the same, or OP, okay, PO square plus OQ square. So PQ square equals to PO square plus OQ square. So, but we know that PO equals to R, OQ equals to R, and also PQ equals to 7 times root 2. So we can put the data in the equation and we will find out. So instead of PQ, I will put 7 times root 2 because PQ equals to 7 times root 2. So it is actually 7 times root 2 square equals to PO square. PO or OP equals to R, so it will be R square plus OQ square. OQ equals to R, so it is R square again. So it is R square plus R square. So this is actually will be our second equation. So in the second equation, R square plus R square equals to 2 times R square, and 7 times root 2 square equals to 49 times 2, because 7 square equals to 49 and root 2 square equals to 2. Okay, so I write it down. Again, 7 square equals to 49 and root 2 square equals to 2, and R square plus R square equals to 2 times R square. So here we can divide the equation by 2. We'll get that 49 equals to R square. So we got that 49 equals to R square. Now we take out, root of the out of the equation, number 2. We take out the root of out of the equation number 2. So the root of R square is R, and the root of 49 is actually equals to 7. So we took root out of equation number 2. As I already told you, the root of R square equals to R, and we have also root of 49, and the root of 49 equals to 7, and the second root of 49 is not possible because radius of any circle must be a positive number. Okay, so we'll take into account only the positive root of 49. So actually we got that the value of the capital R, of the radius of the semicircle equals to 7 units, but according to equation number 2, we know according to equation number 2 that capital R equals to 2 times small r. So we can write it down. According to equation number 1, capital R equals to 2 times R. Equation number 1 states that capital R equals to 2 times R, but we know from equation number 2 that capital R equals to 7, so we can substitute R in the first equation by 7, because R equals to 7 units. So we will get that 7 equals to 2 times R. Here we divide the equation by 2. We substituted R by 7 because R equals to 7. We got that 7 equals to 2 times small r. We divide the equation by 2, and we will get that the value of small r is actually 3.5 units. Okay, the value of small r equals to 3.5 units. We have the area of a circle is actually pi times the radius square. Yes, the area of any circle equals to pi times r square. Yes, area of any circle equals to pi times r square. But we know that r equals to 3.5 units, so we can substitute r by 3.5 units. Okay, we will get that the area of the yellow circle equals to pi times 3.5 square. Okay, I substituted r by 3.5 units, and 3.5 square equals to 12.25. So actually the area equals this of the yellow circle equals to pi times 12.25. Okay, so .5 square equals to 12.25, and pi times 12.25 equals to the area of the yellow circle. So the area of the yellow circle equals to 38.48 units. So pi times 12.25 equals to 38.48 units. So the area of the yellow circle, equals to 38.48 units. Okay, so now I will summarize the lecture. So we actually wanted to find out the area of the yellow circle, and as you know, the area of any circle equals to pi times the radius square. So the only thing that we must to find is the radius of this yellow circle, and then we will know the area of the yellow circle, because the area equals to pi times the radius square. Okay, so we actually connected. We have here a semicircle that O is the center of the semicircle, and the point of contact between those two circles, between the yellow circle and the semicircle, is point P, and PQ equals to 7 times root 2. So we actually connected points O and M is the center of the yellow circle, and we actually have rule, I called it rule number 1, that states that if two circles touch each other internally or externally, then their point of contact lies on the straight line joining the centers. So actually those two circles, the semicircle and the yellow circle, touch each other at point P. Point P actually is the point of contact, and rule number 1 states that this point of contact, point P, lies on the straight line joining the centers. So if we join the two centers together with the segment line MO, then point P lies on a straight line if we connect point P with the two centers. Or in other words, point PMO is a straight line. Again, the line segment that connects the two centers together is the line segment OM or MO, and point P creates with this line segment MO a straight line. That is to say, PMO is a straight line, or also PO is a straight line. Okay, so I will repeat again. If two circles touch each other internally or externally, in our example, those two circles, the yellow circle touches the semicircle internally, then their point of contact, that is to say point P, lies on the straight line joining the centers. Point P together with the segment line that connects the two centers together, M and O, or the line segment MO, creates with point P a straight line. That is to say, PMO is a straight line, or OMP is a straight line. Okay? So actually, according to rule number 1, PO is a straight line, and MO is the radius of the yellow circle, because it exits from the center of the yellow circle and at point O that is a point on the yellow circle, and also MP is the radius of the yellow circle because it exits from the center of the yellow circle and ends at point P that is a point on the yellow circle. For that reason also MP is the radius of the circle, so OP equals to 2 times R, that is the radius of the yellow circle. For that reason also is the diameter, OP is the diameter of the yellow circle. Okay, but because of the fact that according to rule number 1, OP is a straight line, we can define OP as the radius of the semicircle because of the fact that OP exits from the center of the semicircle and ends at point P that is a point of the semicircle itself, or a point on the semicircle itself. So any line segment that exits from the center of the circle and ends at any point on the circle is defined as the radius of the circle. For that reason, OP is the radius of the semicircle, and we call the radius of the semicircle capital R. And we can actually see from the drawing itself that the relationship between capital R to small r, we can see that capital R equals to 2 times small r, or in different way we can say that OP equals to capital R from one side, but from the other side also OP equals to 2 times small r, because OP is also the diameter of the yellow circle. So from this we can deduce that capital R equals to 2 times R. Okay, as you can see here, from one side OP, because OP is the straight line and it exits from the center of the yellow circle and ends at point P that is a point on the semicircle, we can deduce that OP is the radius of the semicircle from one side, but from the other side OP is the diameter of the yellow circle. So OP from the other side equals to 2 times R. So from that two equations we can deduce that if OP equals to R and OP equals to 2 times R, then we can deduce that capital R equals to 2 times small r. For that reason, the relationship between small r and the capital R is that capital R equals to 2 times small r. Okay, and we also have rule number 2 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, let's call it R, and a tangent to that radius that we called it T, then this angle is 90 degrees and also this angle is 90 degrees. And we actually can implement this rule in our circle, because in our circle we have radius MO of the yellow circle, and we also have a tangent to this radius, that is QO. So according to rule number 2, the radius and the tangent to that radius are perpendicular to each other. That is to say, angle POQ equals to 90 degrees. So we know that OP equals to capital R, is the radius of the semicircle, and for the same reason OQ is also equals to capital R, because OQ exit from the center of the semicircle and ends at a point on the semicircle itself. And this is exactly the definition of radius. So for that reason, capital R or OP is the radius of the semicircle. Okay, so PO is the radius of the semicircle, and also OQ is the radius of the semicircle. And we know that PQ equals to 7 times root 2. So we actually drew again the right triangle POQ, and we implemented the Pythagorean theorem in order to find out the value of capital R. And actually the Pythagorean theorem states that the square of the hypotenuse in a right triangle equals to the sum of the squares of the perpendiculars. So the square of the hypotenuse, that is to say AC square, equals to AB square plus BC square. So we can implement this rule in our right triangle, and we can say that PQ square equals to OQ square plus OP square. Okay, according to Pythagorean theorem. But we know that PQ equals to 7 times root 2. We know that PO equals to capital R, and also OQ equals to capital R. So we can put this data in the second equation, and we got at the end to the answer that capital R equals to 7 units. But we know from equation 1 that capital R equals to 2 times small r. So we can substitute capital R by 7 because capital R equals to 7. So we have equation 1 that states that 7 equals to 2 times small r. We can divide the equation by 2, and we got that small r equals to 3.5 units. That is the radius of the yellow circle. And from that we can know the area of the yellow circle, because the area of the circle equals to pi times the radius square. And we know that the radius equals to 3.5 units. So we can substitute r by 3.5, and we got that actually pi times 3.5 square equals to pi times 12.25, and pi times 12.25 equals to 38.48 units. So the area of the yellow circle equals to 38.48 units. You can see the drawing. So the area of the yellow circle equals to 38.48 units. Okay, thank you very much.